So what we found when we plotted these three graphs was that they were parallel lines. So they all have the same value in front of the x. The coefficient of x in each of those cases is the same. And that identifies that they will all be parallel. They're all in the same structural form, y equals mx plus c, y equals mx plus c, y equals mx plus c. And each of those cases, the m is the same, they're 3. And so that identifies that they are parallel. So what we can do is we can write down a general statement that says that for the lines y equals m1x plus c1, so the m1 can be any number you like, the c1 can be any number you like, okay, and y equals m2x plus c2, again m2 and c2 could be any number you like, okay. Then these are parallel when m1 is equal to m2. So if the gradients are the same, then you can tell that they are parallel. Now there is a little bit of a caveat there, because if the C1 and the C2 were the same, then you're working with the same line. Okay, so if M1 and M2 are the same and C1 and C2 are the same, then you're working with the same line. So sometimes refer to that as concurrent lines. Okay, we wouldn't really call those parallel because they're the same line. So quite often you would see a restriction on that and say, well, these are parallel when M1 equals M2 and C1 does not equal C2. Okay, because otherwise they're going to be overlapping one another. Otherwise, we would be able to say that y equals 3x plus 2 and y equals 3x plus 2 are parallel lines. Is that really helpful to say that? Not really. It's more helpful to say that they are the same line. Okay? But what we can say is that these two lines are parallel. Okay, they have the same gradient, but the y-intercept is different. So 2 and 200 are different. So these are parallel. We could also say that y equals 6 take away 8x and y equals 5 take away 8x are also parallel. Now, the reason why, because these aren't quite in that same structural form, are they? But we can write that as y equals minus 8x plus 6 and y equals minus 8x plus 5. Okay, so you can write them in an equivalent form, in that form, and see that the coefficient of x in both those cases is minus 8. And so, because they're the same, and these numbers are different, that means they must be parallel. You do have to keep an eye out though. So let's say I had this. So 2x plus y is equal to 3 and y equals 2x plus 5. Are these parallel? Well, upon first sight, you might say yes, because the number in front of the x in both these cases appears to be 2. And so, because they're the same, you might think they're parallel. But they're not in this structural form. The second one is, the first one is not. So if I subtract the 2x from both sides, I get y is equal to minus 2x plus 3. And now, because it's in this form, you can compare them. So only when they're in that form can you properly compare their gradients and their y-intercepts. So here the gradient is minus 2, here the gradient is 2, so they are not parallel. Okay? So that is how you can identify whether two lines are parallel or not.